Welcome to ClickMyProject.com. Now we're going to discuss about the project rice grain classification using multi-class support vector machine. Now we're going to discuss about the abstract of the process. The main purpose of this process is to present an image processing based on the solution to classify the different varieties of the rice grain, an approach based on the combination of feature extraction, classification and performance estimations. Variety of rice grain is determined by the morphological features such as the HSV, mean standard deviation, variance of the rice grains image. The dataset consists of the different kinds of rice grain varieties which having the lot of varieties. The classification is done by comparing the sample image with the database image. Hence the SVM is used to detect the type of the rice grain. Then the classification performance will be evaluated based on the accuracy, sensitivity and specificity. Hence in this process we have three kinds of modules which plays a major role in the process, that is the feature extraction, classification and performance. In this feature extraction, the values which having the rice grains having the different kind of features which will be extracted using the feature extraction. After the feature extraction, we are just doing the classification to classify the type of, that is the variety of the rice grains. Then the performance, already we have discussed the accuracy, sensitivity and specificity. Based on this parameters we can justify our process is efficient or not. Now we are going to discuss about the overall working flow of the process. This is the overall working flow. The module consists in this project is the input, pre-processing, feature extraction, classification and performance estimation. Why now we get into the flow diagram. First of all, the dataset consists of the different kinds of rice grain varieties. Then in the input stage we have to get any one image as an input. After getting the any one image as an input, we just move on to the next stage of the process, that is the pre-processing. In this pre-processing, the grayscale conversion is enough for the pre-processing because most probably the noises will not be there in the datasets, so the only the grayscale conversion will be enough. After the grayscale conversion, the feature will be extracted from the grayscale image. In this feature extraction, we have a feature extractor by means of the mean, standard deviation and variance. By using these three parameters we are extracting the features from the image. After the extraction of features, we just move on to the classification step. In this classification step we are using the support vector machine classifier to classify the type of the rice grains. The input of the classifier will be the three kinds of input. One is the test feature, then the train feature, then the labels. The test feature consists of the features of the input image, then the train feature consists of the features of overall dataset images, then the label consists of how many varieties of rices we have in the dataset. For example, I have 5 varieties of rices in my dataset, means the label will be the 1 2 3 4 5 like this. Then finally the performance estimation. In this performance estimation we have to analyze the performance of the classifier by means of the three kinds of performance estimations like accuracy, sensitivity and specificity. The level of accuracy in terms of in the percentage will justify our process is efficient or not. Now we are going to discuss about the initial running procedure of the process. At first open the Matlab 2015b and change the current directory. If you want to execute the process, just right click in the main_gui.m and select the option run. Now the user interface was open. In that user interface you can see the several push buttons in the right side for the controlling actions, and then the several axes and tables in the left side for the display purpose. First of all, we have to click the button input image. After clicking the button input image, you have to open the dataset and then you have to select the image from the dataset. The dataset having the lot of rice grain varieties, so among that I have select any one image from the dataset. The selected image is shown in the axis 1 with the title of input image. After the input selection, we just move to the next stage of the process, that is the pre-processing. In this pre-processing we have two kinds of pre-processing is there. The major thing is the grayscale conversion. In between we have included the resize. In this resize we have resized the image in the size of 256 cross 256, which means the number of row will be the 256, number of column will be the 256. Once the image is resized into an aspect ratios, we have go for the grayscale conversion. In this grayscale conversion, the RGB image is converted into a grayscale form like this. After done the pre-processing, we just move to the third stage of the project, that is the feature extraction. In this feature extraction, we have three kinds of feature extraction will be there: mean, standard deviation, and variance from the HSV image. HSV image will be first of all generated like this. Then by using this HSV image, we are extracting the mean values, standard deviation values, and variance values like this. After extracting the features, we are just move to the next stage of the process, that is the classification. In this classification, it will shows the type of rises present in the image. The classification results should be shows whether the input is an basmati or whatever it is. It will shows the input rice grain type. After displaying the results like this, we are just move to the final stage of the project, that is the performance estimation. In this performance estimation, we have three kinds of performance, that is the accuracy, sensitivity, and specificity. The accuracy will be in terms of percentage, then sensitivity and specificity also in terms of percentage. Here we are achieved the 99.5% of accuracy. Thanks for watching this video.